Welcome to The Explainer. Today, we're diving deep into one of the most powerful and maybe mysterious numbers in your financial life, the credit score. We're going to pull back the curtain and see exactly how these things are built from the ground up. So, think about it. At the end of the day, lending is all about trying to answer one single question: are we going to get paid back? It really just boils down to predicting the future. And to do that, banks build these incredibly sophisticated rating and scoring systems. Their whole job is to separate the good risks from the bad. Okay, so let's get right into it. First, we need to understand why these ratings are so incredibly important. It's not just about a simple yes or no on a loan, it's about measuring risk with unbelievable precision. And wow, this chart really tells the whole story, doesn't it? This is historical data from Moody's, and it shows that for the absolute best-rated borrowers, the chance of defaulting in a year is next to nothing. But look what happens as the rating goes down. The default rate just explodes. A B3-rated borrower is over 120 times more likely to default than someone with a AAA rating. That is the power and the stakes of a good rating system. So that's the whole point, right? A credit scoring system is basically an engine designed to sort financial futures. It's trying to approve the good applications while setting the price, the interest rate, just right, so it's high enough to cover the losses from the loans that inevitably do go bad. Okay, so a bank goes and builds one of these complex prediction systems. But how do they know if it's actually any good? How do you check your work and make sure you're not about to make some very, very expensive mistakes? Well, that's where quality control comes in. It's really a basic test, and there are two big ways a system can fail. It can reject someone who actually would have paid back the loan, and that's lost business. Or, and this is much worse, it can approve someone who ends up defaulting on their loan. This tool right here is called a confusion matrix, and it lets analysts see exactly where their model got it right and where it went wrong. The green boxes, those are the wins, but the red boxes, those are the errors. A type 1 error is a missed opportunity, but a type 2 error, approving a bad loan, oof, that is a direct hit to the bank's bottom line. The whole game is to make those errors as small as possible. Now, to get an even better view of how powerful a model is, analysts use something called a ROC curve. It's a really clever way to visualize just how well the model can tell the two groups apart, no matter what cutoff score you use. And this shows you exactly how it works. That diagonal line through the middle, that's just a random guess, basically flipping a coin. The more your model's curve bends up and to the left, the better it is. You can see on the left with the training data, the decision tree model looks like the winner. But look at the right. On new data it's never seen before, the story changes completely. So let's get into the nuts and bolts of how these models are put together, starting with the classic, time-tested approach that's been the industry standard for a very long time. For decades, the go-to tool has been logistic regression. Now, don't let the technical name fool you. You can just think of it as a method for creating a very carefully weighted formula. It takes in all these different inputs, things like your income, your age, how much debt you have, and it spits out a single number, the probability that you'll default. Building one of these is definitely not a simple plug-and-play operation. It's a real craft. As you can see here, analysts start with tons of potential factors. Then they have to figure out the predictive power of every single one. After that, they group similar values together in a process called binning, which actually makes the model more stable. And finally, an automated process helps them find the absolute best combination of factors before the whole thing gets tested on data it's never seen before, just to make sure it works in the real world. But of course, today, logistic regression isn't the only game in town. With the explosion of machine learning, we now have a whole new toolkit with alternatives that are way more complex and sometimes way more powerful. And this really gets to the heart of the trade-off. You've got these newer models like neural networks that can spot patterns that the older methods might miss, so they can perform better. But, and this is a big but, they come at a cost: transparency. A logistic regression model is pretty easy to explain. You can see exactly how the sausage was made. A neural network? Well, that's often a black box, which makes it a lot harder to understand or defend its decisions. In fact, this is something you see all the time in the real world. This quote here really nails it. It says that even though the more complicated models looked better on the data they were built with, the classic, more transparent logistic regression model was actually more reliable when it was hit with brand new data. And in the world of financial risk, reliability is often way more important than raw power. So, a borrower gets a score. That number is obviously a huge deal for them. But how does that little number ripple outwards and shape a bank's entire strategy? Well, the impact is absolutely enormous. It all comes down to this regulatory idea called risk-weighted assets, or RWA. The easiest way to think about it is that not all of a bank's loans are treated equally. A super safe mortgage is a lot less risky than, say, an unsecured loan to a brand new business. And here's how that plays out. A loan to a borrower with a really low probability of default, a low PD, gets a low risk weight. But a loan to a high-risk borrower, that gets a much, much higher risk weight. And what that means is the bank has to set aside a lot more of its own money, its own capital, just to make that one risky loan. And that's really the core principle of modern banking regulations like the Basel Accords. It creates a direct line between an individual's credit score and the overall stability of the bank, and even its ability to keep lending. Riskier loans use up more capital, which naturally limits how many of those loans a bank can make. It's a powerful way to encourage careful lending and protect the whole financial system. And that brings us to one last big thought. These scoring systems are getting smarter, more complicated, and way more automated. But as the models become these black boxes, it raises a really tough question. When an AI-driven system gets it wrong and denies someone a loan they deserved or misjudges their risk, who's actually responsible? That's a question we're all going to have to answer as this technology keeps reshaping our world.